ready, you know, it's not always that you get your first choice in Keynote. We really lucked out this year that Jessica Kerr was available. I'm so excited. Many of you know her as a keynote speaker and have heard her speak before. Some of you might know her as a dev, an engineer from Honeycomb. I know her as a leader in observability. And I just learned this too. She is actually pairing with Kent Beck on some really cool stuff. They've got a website, systemthinking.dev, that they're collaborating on. So that was a new one to me. So I'm still learning stuff about you, Jessica, and welcome.
Thank you, Steve. You want yours? Whoops. Sorry. Okay. Sounds like the mic is working. Great. Now computers. Slides. Okay. The slides are, wow, they're really far away. Fortunately, they're not that important. Okay, how many of you flew Southwest this Christmas, or were close to someone who did and were affected by this mess? One? Seriously, does Southwest not? Three? Wow, Southwest must not fly much here. It's all Delta, okay. Lucky you. Because St. Louis has more flights out of Southwest than anything else. And it was a mess. People were stuck for so long. My partner was stuck in Pennsylvania, and Avdi had to rent a car and drive back. He was lucky. He could rent a car and drive back. But like 11,000 flights were canceled. And they were canceled not just like, oh, you'll get on the next one, but try again in 3 days to get home from Christmas. It was a mess. And specifically Southwest, all the airlines had problems on the 22nd. This started before Christmas. There was a big storm on the 22nd. I know because I was supposed to fly home from Arkansas that day, and I did not because the flights were canceled. And United's app said, try again in 3 days. And I called them and I said no, and they said, okay, you're going home tomorrow on American. But the other airlines just all recovered. You know, they had a bunch of flight cancellations. It's weather, it's normal, this is fine. Except it's not normally during Christmas and everything was packed and it was a mess. But their mess ended. And then the week after Christmas, weather's not really a problem, but somehow Southwest is still full of cancellations. And day after day after day. And the reason was their software that decides like whether you can fly and gives people approvals and figures out the routes, it doesn't understand this concept of cancellations. People manually have to input the location of the crew every time a flight is canceled, as if that were abnormal. And the software has been around since the 90s. They're still using it. They're still having people handle all cancellations. They're still having people handle, talk to the crew, like with mouth words on the phone to tell them where to go and like what hotel to stay in tonight and stuff like that. And it just got to be too much. It collapsed. I did find one person who said there was also a software error, but most people were like, yeah, it's worked like this forever, and it just got overloaded and we just lost it. We entirely lost track of where all the crews were. The crews were there. Sometimes they were on the plane and they just couldn't get the authorization to fly. And the system was tanked. And they had to take 3 days of mostly canceling like 60 to 70% of their flights. They got a few of them going, but mostly they just shuttled crews back to where they were supposed to start from so that they could start from scratch on Friday. It was a mess. People were like hitting refresh on the website to see if there were any new flights that they could jump onto because, right. So this cost them at least $800 million. half of that in just refunds for the canceled flights, straight lost revenue, and half of that in Opti's getting his car rental reimbursed. They'll give him $500 back for the expense of renting a car. And to say nothing of the reputation. That isn't measured. But they were supposed to be profitable. Last quarter, they were going to lead the major airlines in profitability. No profit for you, Southwest. Not this quarter. So that was a pretty big failure in the resilience of their system. Also, there was a great one yesterday. So there's this system that the FAA has. Also, presumably an ancient software system, although I hear it's been modernized and digitized and privatized in the last 15 years. This system is called NOTAM, Notice to Air, used to be Airmen, now it's Air Missions. Good job. This has not failed since it started in 1954. Thanks, Brad Kane, for that information this morning. But it's basically a status page. The status page went down so nobody could fly. It's a much more cryptic status page. You can't actually read it. And also, Brad tells me that when you get the NOTAMs for a flight, which is supposed to tell you whether like any runways are closed or are there any weathers expected, like what do you need to know for this flight? It's like 30 pages of this gobbledygook. But apparently, you can't fly without this. I mean, you do need a way to know whether it's safe at the airport you're flying to. And this is the way that the FAA has. And so when it went down, they're like, a few flights got off the ground that morning, and then they're like, crap, how are pilots even gonna know if like the airport is closed that they're supposed to fly to? We have to ground all flights. And so they ground all flights by, oh crap, they can't make a NOTAM about that. They had to like find other ways to do this. One source says that they tweeted, which how do you know it's the real FAA? I mean, for $8, I could be the FAA tweeting to ground all flights. I wonder how that would work. Anyway, United grounded flights before that, but eventually the FAA used the air traffic control system to ground flights and just asked people to not fly until they could get this system back online so people could get their 30 pages of gobbledygook just in case there was something important. Information matters. And this is interesting because it's not just one airline with their antiquated software system going down. All of them are affected. Which ones will bounce back? So yesterday I hear about this and I'm going to the airport and I'm like, am I gonna talk about resilience tomorrow? I'm on United, yes. Southwest yesterday did have the highest percentage of delayed and canceled flights. It was like 49%. United handled it so well that I got here early. They like rearranged my schedule. They're like, take this, your flight is delayed. Take this 10:30 flight to Chicago. I'm like, it's 10:28? And you want to put me on the 10:30? But I'm through security, so sure. Yeah, that worked out. So the different airlines handled this particular outage a little differently, but it wasn't enough to tip Southwest into the can't handle it territory, we hope. But we'll see how today goes. The difference in whether you have a day of canceled flights and a day of bad weather, or a week of canceled flights, half a week after a day of bad weather, is resilience. Southwest did not demonstrate resilience, and it cost them a lot this time. But since the theme is resilience today, I want to define that and define some related words, starting with reliability. Reliability is how often do you do this thing that's expected of you? Can you perform consistently well? For instance, in 2019, Southwest had like an 80% on-time rating. That's reasonably reliable, I guess, for an airplane. United was only at 75. United out of St. Louis was quite lower, I assure you. But reliability is something you can measure. It's something you can observe. In software, sometimes we measure this in uptime, but then you have to define what is up, which is tricky. I like to measure it in percentage of events. How many times did a customer try to use your system, and how many times did they succeed in the amount of time that we find acceptable. You can measure reliability. Similarly, robustness is another property that we like of our systems, and this is how do you handle different conditions, under what conditions does it work, and including rigorous testing. So robustness is something you can test. You can load test and performance test your system and say, okay, we're gonna be okay up to this load, for instance. But then there's everything else that could go wrong. Resilience is about the everything else, and it's about the how. How do we get reliability and robustness? Resilience is the capacity to recover quickly from difficulties. We don't avoid incidents by not having incidents. That's not a thing. I'm told by our SRE team that one time they tried to have an OKR goal of having fewer incidents, which led to them, is this an incident? Nah. Which led to them having fewer incidents, acknowledging fewer incidents. And then they learned, okay, don't make your goal get lucky. It's not helpful. What matters is when something happens, how do you bounce back? I also like, that was the Oxford Dictionary. The Cambridge Dictionary has two nicely juxtaposed definitions. One comes from material science and apparently biology, where resilience is the ability of a material to bounce back when deformed. So your car bumper has some level of resilience. If you just push in and on it a little, it'll bounce back. If you push it hard enough, it keeps the dent forever and is past that, and that's fine as long as you're okay. But that's one definition. And the other one comes from psychology, and that's the ability to be happy, successful, et cetera, again, after something difficult or bad has happened. This isn't just bouncing back to be the same as before. This is becoming someone new who can live in a world that's different. So your parents die, that's a thing. And we all have to become someone who's actually like the oldest generation in our family. It's different, and it's really, my parents are still alive, but I observe that it's really hard. Or a partner leaves, a partner that you were like deeply integrated with, and you can't just go on living. You have to become someone who doesn't live with them. You have to become someone who lives on your own or with the other people who are around you. We have to change in response to our circumstances changing, and that is also resilience. So resilience is recovering from events by bouncing back, and from change by becoming someone different. And this is a whole spectrum. Software can help you with the first one. We need both of these things and everything in between. Software can help you with the material science bounce back into shape. Kubernetes is exactly this. So Kubernetes is infrastructure abstraction, and you tell it, okay, I want 5 instances of this web server running on different hardware at any given time. And when one of those instances crashes or runs out of memory or just stops responding, Kubernetes will be like, you're done, pop up a new one. And then there will be 5 again. Kubernetes is perfect at bounce back. It's not helpful with succeeding under new circumstances. Software can't do this for us because we can't define in software who we need to be. So if your customers have new standards, and that, did you see that NOTAM? You know, we're a little past teletype, and people want stuff to be intelligible. They want it to have dark mode. They want it to come to them in text or email or on the web or through RSS, or standards increase, and we need to adapt to a world that has that. That has that expectation. That's an easy one. And of course, this takes changes to the software, and that comes from people. Also, like in security, so when an attacker comes up with something entirely new to throw at your system, whether it's quantity or maybe it's coming from all over the world, or maybe it's a secret string that only recently has anyone discovered will do something weird in your logging system. New stuff comes at us, and we need to react as people. The serious resilience and the resilience to change is in the humans. We can't expect that of the software, but we can put some of the routine stuff in software, and that's helpful. So we're here, we're in the middle, we need both of these kinds of resilience. It takes software and people to get there. I'm going to talk about like some places that this resilience comes from. But the theme here is that resilience isn't something you can impose top-down. I mean, the top-down decisions totally make a difference. They certainly did at Southwest. But it's also kind of everywhere. It's in the small stuff too, and we can improve resilience and our work experience at the same time by paying attention to the way that we work. Are we working in a way that lets us bounce back? And are we working in a way that we're becoming a team that's better at doing our work? And are we improving the experience of teams and companies and people and users and software that works with us? Is this getting better over time or harder? Are we just working harder all the time? And I want to say that working harder isn't going to make us better at this. That makes us more brittle. Giving us some space to take a breath and make our own jobs easier is going to make us more resilient and also happier. It works out. Okay, so resilience is about recover from surprise. I want to put a scope on this system. It's easier to talk about if you support your software in production. How many people support software in production? A lot. Oh, great. Okay, sweet, good. And resilience there, you can look at the resilience from the perspective of people who use your software. I also want to speak about development tasks itself, because a lot of teams don't get to support their software in production. They're just delivering code. And there's resilience there too. You can define resilience as the ability to deliver something every week or 2 weeks, whatever your cadence is, and be able to deliver anything eventually. To not have surprises very often that are like, okay, so we want to support Unicode in customer data. This is something Honeycomb did like 2 years ago. Personally, we use it for emojis. We put emojis in the names of everything. Really, the more compelling use case was for international characters. But we're like, okay, yeah, we should be able to support Unicode. That's a good requirement. And then you get to implementing it, and you're like, we're going to have to specify a different encoding for the strings in the database. And you can look that up and see that MySQL supports that, and you need to specify this encoding. Oh, and then you also need to specify how to sort that stuff, because alphabetical is not clearly defined in Unicode. And then you go to implement that, and crap, that's 2 versions newer of MySQL than what we're running. And now you have a whole migration process involving multiple copies, because you've got like multi-step migrations going on. And now supporting Unicode, it was a matter of months. It was a couple months. It was a lot of work and a whole thing. And that was like a surprise that took us a while to recover from, because we weren't in a place. Being on the latest version of the technology that you're using is resilience in the software experience, because then you can upgrade it, then you can use what you need, and then you can use this new React package that requires this version of React and doesn't conflict with this old version of this other thing that you're using. Versioning is hard. So that's a form of resilience in development, is how often do you get those surprises and how quickly can you upgrade. So the systems that I'm talking about here as software teams include both of this. It does include development, production support, and the running software itself. And that's because I want to define a team here as everyone required for me to be successful. And as a developer, I consider success to be operating useful software in production, providing software that provides let me start again. I consider success to be providing useful capabilities to customers, whether those be people or other software inside the business or outside the business. For that, I need my software to be running, and therefore, I put the running software on the team. Because this resilience that we have, it's between people and software. It includes both of us. So consider the software a teammate. It can be a good one, or it can be a recalcitrant one sometimes. But also, not just the software that we operate, but all of the tools. The whole tool chain that lets us deploy that, from the IDE to version control, to the builds and the automated tests, and then what lets us find out what the heck is going on. So our observability and monitoring, and admin consoles, a database prompt, we used that the other day. All of this forms a socio-technical system that overall is trying to provide reliable, robust capabilities to customers by being resilient. Okay, some sources of surprise in this system can be both social and technical. So you've got, hardware can go down, network is not reliable, don't think it is. We need to build reliable systems on top of unreliable networks as much as we can. Sometimes, if it's worth the money. The other software that we interface with, that can change and surprise us. But also on the social, and security vulnerabilities. This is, I love security problems now, because it gives me a reason to explain to the business why we need to be able to keep our libraries up to date. I mean, it's not personally the reason that has a big impact on me. That's just I can do stuff in a modern way. But security gives me a reason that everybody can understand. No, we need to be up to date on this, or attackers can get in. Also true, and it's useful. To get reliability, you have to sometimes talk about its opposite. Okay, so that's a source of surprise. But also the people who use our software, they're going to use it in ways we didn't expect. And they're getting errors. And do we care? It's fun to care. I like to care about that. I like to go back and fix some of those and not just be like, 100,000 Sentry errors this month. Okay, guess that's normal. It is normal, but man, it's satisfying to get that number down. And then the business that we're part of. That business is growing, and it wants to provide new capabilities, and we need to respond to what the business needs or asks of us, in addition to providing it information. A lot of these sources of surprise are also sources of resilience. In particular, our users can be sources of resilience because they learn how to get around our errors. And they post this on the internet, and this is how Microsoft works. Well, really everything, and Apple, and this is why the most popular products are also the most usable, because the functionality doesn't come only from within the product itself. It's also in the community around it. Modern games these days can't be played without Google and YouTube. They're too hard. You'll never figure out all the puzzles. You try for a while, and then you'll look it up. How do I kill this boss with this character? Oh, well, so you need to look for the pattern. First he's gonna go over here, and then he's gonna go over here, and then you need to run away for a bit, and then you come back and smack it. The community around a product matters and actually increases the resilience because people can do more with it. There's a lot of resilience coming from the rest of the business. For instance, I didn't explicitly include support in the system that I'm talking about, but that is absolutely where a lot of resilience comes from. In Southwest, they've got those people entering the cancellations and the crew locations manually, and that's how they survived for 20 years. I was leaning on the people. So if you think that your software is solid, go talk to support. Talk to the people who the customers call when they have problems. And it's a wealth of information about what really happens. Okay, I want to talk about some places that we get resilience through a bunch of little stories, ideally. And it starts with I had to put this one first because it's the biggest. You can't have resilience, and certainly not sustainable resilience, without some slack. And sometimes slack means the autonomy to decide, hey, no, I'm going to upgrade the database now. Okay, that's kind of a big one. You would actually probably plan for that one. It's going to take a week even on a good upgrade. But I'm going to update our version of this package. I'm going to convert these tests to React. Or I noticed something and I'm going to investigate it. For instance, last year, someone at Honeycomb noticed, just like randomly in the admin console as they were doing something else, they noticed that the ID for a data set column was really big. It was like in the millions, and they hadn't seen one more than 5 digits before, and they were like, huh, why is that? And then they posted something about Slack in it, or in Slack about it, before they went about their other business, and someone else got that question and thought, huh, that's really weird, and went and poked around some more, and sure enough, we were burning through dataset column IDs, and in another week, we would have run out of numbers and had an overflow on that ID column, and that would have been really bad. That would have been bad. But because someone noticed this and had the brain space to say, huh, and someone else responded to the question and had the space to like really dig into it, then we recognize the problem. And if you're like heads down, always working on the most important thing, you'll miss this stuff. Other forms of slack, airplane seats. Yesterday was not, in fact, the week of Christmas. And so United was able to handle the FAA outage and the delays by like, these 2 flights, they're all going on the same plane. Because they had plenty of extra seats. Neither of those flights was half full. So when there's Slack, you have so many options. You have so much more to do. The easiest way to support more users is to throw more compute at it. When I worked at Stripe, which was like 5 years ago, we used to run our web servers at like 40% load, like 40% of capacity. We'd have tons of extra capacity just to handle spikes in demand. It's the least complex way to get that resilience is to have a ridiculous amount of slack, but that's expensive. There was a good one the other day where Circle CI had a breach, and everyone had to log in and like deactivate their keys and put in new keys so that their builds could work again. And at Honeycomb, the SREs remarked, they were like, you know what? Slack usually has, it's got many thousands of users, but at any given time, maybe a dozen of them are swapping keys. But now everyone's swapping keys at the same time. And they're like, I only had to hit refresh like twice. It was impressive. So there was enough slack, apparently, in Circle CI's system to handle a big, maybe they bumped the allocation of some stuff. But they did a good job handling more than their usual load. And Slack is the easiest way to do that. The worst way to do that is just to have people working really hard, like at Southwest. Or one of my friends is on production support currently for this banking software that's new. It hasn't, like, robustness comes over time, and this one doesn't have it yet. And every time the user doesn't, their account creation, they're trying to create an account and it doesn't work, well, you wouldn't want to tell them why it didn't work. apparently. That's a business decision. You present a generic error message and a number to call, and then you call the number, and then they talk to someone in support who has no freaking clue why that didn't work. How would they know? The UI just ate the error message. They have to call through to a developer, probably making at least $100 an hour through the consulting contracts, to go dig through Splunk logs to find out why that didn't work. No, that is people working too hard. Don't lean on your people that much. Use your people for adaptability. Counterexample, yesterday, someone at Stripe tweeted that, oh look, we put the log URL in the API response so that support can get to it right away. Handy. What you do want is people doing what needs done. If I walk across the living room floor and there's just stuff everywhere, and at some point I'm like, no, I want to walk across the floor more easily, and I start picking up the stuff. You want that in your code. You want, oh my gosh, I don't understand this, I need to refactor it. Not like all the time, every time. If it's stuffed animals on the floor, okay, maybe I'll just kick a couple of them. If it's Legos on the floor, stop and pick up the frickin' Legos, because I don't want to step on those over and over. No, it's a difference. We can do that in our work. Oh, I got this error message. What does it mean? This. No, I just lost half an hour because it actually meant something completely different. Let me fix that right now so that the next person won't step on that Lego. And then it's really nice. I was working on the Honeycomb UI some months ago, and I needed like this functionality, this component. I looked it up, and it's like, oh yeah, that's totally in the latest version of React. The latest version of React. And I go back and I look at our package.json, and it's like 17, and I'm like, woo! That just made my job so much easier because I can use the latest. Or the documentation is updated. Oh, I got this error when I tried to run it. Oh, there it is in the README. I know just what to type. This is the stuff that like makes our work smoother, and that's the level of work that we need to be doing, of stepping back and saying, I care about my experience was rough, I'm going to make it better for future me and the rest of my team. Another thing that we do to build in resilience is give ourselves options. We deployed service maps at Honeycomb a few months ago, and this is a big new feature. It involves all kinds of like additional data processing on ingest. Every time you send us an event, we're not only recording the event, but we're noticing what service called what other service, and we're putting that in a different data set so that you can draw a map of your services. And so this was a big rollout with there's a lot more that's going to run in our infrastructure. And so the team, Violet, I think it was, that was working with the SREs for this deployment, the SREs aren't like, how do you know it's going to work? Can you prove it won't impact our system? No, you can't prove that stuff. That's not a thing. What we do is, when it impacts the system, I mean, if, but probably when, how can we react? What levers do we have? So there's feature flags in front of it, and the Violet team is like, okay, this part is not customer facing. You can turn that off if you need to at any time. Or you can turn it down to like 10%. And this other part is customer facing, but it's behind a feature flag, so it'll impact these customers, and you can talk to them through their customer service reps if you need to. It does come down to talk to a human pretty often. So giving ourselves options about how to gracefully degrade the performance of the product. This is more work, but it's also more ability to recover, and it makes everything less scary. And then the deployment winds up being less work because we didn't have to do rigorous performance testing. And when there's a problem, we can roll something out quickly because we have a clear path to production. I'm guessing Jeff will talk about that later, so I'm not going to harp too much on how much a quick lead time to deploy matters. But in Honeycomb, we're big on test in production, and I have a shirt that says I test in prod, and I go to like QCon and some of the software architecture conferences, and people are a little scared. I'm like, I test in production. I don't only test in production, I also test other places. Chill out. But also, do you test in production? Because your customers are. Are you looking at the results? And that's where we get into feedback. You need to be able to see what's going on in your system. This is so crucial to resilience. Directly affects reliability and robustness. Can you tell what errors are happening? And this is why I work at Honeycomb, because Honeycomb works on observability, on making this clearer, so you can see stuff like we're not meeting our SLA. We said we'd accept 99.99% of incoming events within 5 milliseconds each, and we're not. What's happening? And can you dig in and figure out why? Oh, these machines are running out of memory and being restarted by Kubernetes. So Kubernetes here, there's a lot of examples of automated resilience, like Kubernetes restarting yourself, that masks what's happening. Clearly, if Kubernetes is restarting your app every 5 minutes, there's something else you should look at. But you can go for a while without knowing that. Well, I read a good article about another plane that almost crashed because they had a fuel leak, but the computer's just compensating. The computer's just like, oh, well, we'll just put some more fuel in from the tail tank, the trim tank, and then, and then there's a fuel imbalance when that got empty, and then they're like, oh, well, we better move some fuel from over here to over here. No! Don't move the fuel from the good tank to the leaky tank. But the computer just, like, in all of its trying to help, masks what's going on. So that happens to us. And we need to be able to see the computer was not giving them good visibility into how much fuel is in the aircraft, and when that dropped well below what they needed to get to their destination. Yeah, so observability, super valuable. One of the little things that I do that makes my life easier is when I can't find out exactly what's happening in production, when it doesn't come through in the trace, did it use my new feature? Add it in. And then hope if you have a quick deploy pipeline, that shows up in like an hour. But even if not, I can see it immediately in dev. Make my own life easier is a big part of this. And then your other source of feedback is customer support. Talk to them. Get to know these people. As DevRel at Honeycomb, I get to be glue. I get to like work with the engineers and also with marketing, and also I sit in on customer supports meetings, and I stalk their Slack channel to find out what problems customers are having. And I get to know them as people so that when there's something interesting going on, they're comfortable talking to me, and I can ask them, because relationships are a huge source of resilience. Relationships are where you find out all the things you didn't know you needed to know. And if you're comfortable asking someone, it's so much faster. And this is especially internally. Another Jessica and I were pairing the other day, and we're in the query annotations, and we're like, oh my gosh, what even is this doing? Is this valid? And it helped to know that you can do a get blame on the code, and it all says Toshak. But we know Toshak, and we're perfectly fine pinging him in Slack. We don't feel bad about, ooh, is it okay to bother him? You know, we can ask him what the latest problem is with his landlord, for instance, and make this a pleasant conversation. When I need to know something internally, I want it to be like, oh, I have an excuse to say hi, instead of, oh my gosh, is it okay to bother them? And that smooths these communications. Also, it gets you some serendipity in the sense of, you're doing what? Oh my gosh, I didn't know we were changing that. It gets very useful. And then outside of the company, like people you meet here today, you can ask people, what do you like questions about? Like, I love it when someone's like, I've screwed up my Git repository and I don't know what's happening. And I'm like, ooh, let me look. I'm that person at work. Whatever that is for you, find out, share that with other people. Ask people today while you're talking, what's like your thing that you enjoy questions about? Liz Fong-Jones at Honeycomb is always like digging into the performance of our Lambda functions, because we spend way too much on Lambda, and it's just one function, and she's always optimizing this. And when she gets to something confusing, like why isn't this using the native library, why is it doing something else, she'll call a language maintainer because she knows them. And that helps. So relationships are huge. And then surprisingly, we got a lot of resilience from outside the system. You don't think about this, but when our resilience fails us, something outside hopefully often eventually compensates. So people can read error messages. When my checkout request doesn't work multiple times, I'm like, all right, crack open this console, find the 500, dig into the response JSON and find out, oh yeah, it says I typed in the credit card number wrong. Why couldn't you tell me that? Because testing is hard and Safari isn't Chrome. But this is like my hacking to make your website work. So people can respond to that. If you give them good error messages, then lots more people who don't know how to dig into the JSON in the developer console can fix their credit card number. Or people, if you give them access to the data, they can run their own reports. And Honeycomb will only give you one type of graph. But if you want to put this table of data of customer last name to average response time, if you want that in a bar graph, export it into CSV and put it in Excel, do anything. So flexibility comes from outside the system when you offer that to people. Integrations, Honeycomb isn't going to text you, but we will integrate with PagerDuty. And it's much better to fit into the ecosystem than to try to do everything yourselves. Because you are not the center of your customers' lives. Don't try to be. Integrate with what they're already using. Very friendly. And then other companies, like Southwest doesn't book people on other airlines. But United put me on a flight on American, and I got home on the 23rd, and I didn't have to stay in Arkansas. Well, I wouldn't have stayed in Arkansas for 3 days. I would have driven a car home, which is on a later slide. Right, so you can facilitate that kind of support from outside the system. It's all about taking a little extra second, and you have to have the breath to take that second, to be like, how could my experience be better? How could the experience of people who work with my system be better, or software? It comes from all over the place. And it's very different to ask, do I have resilience, than to say, does my program work? So much easier. I love how programming is deterministic. Software is not. Software and software systems live in the, and what else happened world. Does it participate in the world as it changes? And it's not a matter of, do I have resilience, but where is the resilience? Is the resilience in your customer support team doing all the work? With the flight example again, yesterday, United had extra flights right there. The resilience was right there within United. On the 22nd, they had to go farther and put me on American. It was outside that. But Opti on Southwest didn't even have that, so he rented a car. So we're falling back to finding resilience in the transportation system as a whole. Fortunately, you can get rental cars these days. And beyond that, you fall back on family. And all of this required him to have the $500 to rent the car. So there's a lot of resilience in financial security that not everybody gets. So just look for where is the resilience. And sometimes you have to move outward. When you're having a hard time at work, okay, can you like, if you're doing too much and you're stressed out, or you have a bunch of doctor's appointments this week, can your team take some of the load? At some point, you're like, can I get a different job that supports me better when it's not? And you find a resilience in having a career versus a job. Look for the resilience at all layers. Good luck measuring it. This month's edition of Communications of the ACM has something about measuring resilience and formulas. In very abstract networks for very specific failure modes or definitions of failure, not partial failure, you can like make formulas about resistance. But when you measure it, you don't measure it directly. You measure the lack of it. You measure failures that happened. You measure failures that were serious. But you can notice resilience, and every failure is an opportunity to notice resistance. Every time there's an incident, why wasn't it worse? Why doesn't this happen all the time? Notice the positives in your system and then amplify those. Look for those successes. Because we talk about learning from failure, but the best way to learn from failure is to learn from the successes that it exposes. Yes, you got an error message. That's good. We can make the error message better, sure. But look for the people who contributed, and then do more of that. So the opposites of resilience are fragility, cascading failures, panic, or in the case of change, eventual irrelevance. If you're not responding to the system, you eventually become irrelevant. But there's some other opposites that maybe are scarier in the sense of, no, you can't have both resilience and maximum efficiency. Resilience eschews perfection. It says your software is never perfect. It's just good in more and more circumstances as it gets better. That robustness increases over time. And stability is the enemy of resilience. Stability says don't change. And resilience says react to what happens and change to match the growing environment around you. These are in conflict. And resilience is expensive. If you want to add a 9 of availability to go from like 99.9 to 99.99% availability, expect an order of magnitude increase in cost just for compute, just to AWS. And then there's the people and the additional complexity. You don't want this everywhere. I mean, you need to have some resilience and notice when you need more, but you don't want it everywhere. I mean, because it involves a lot of waste. And here's the thing about waste. Here's an example of some waste. Look at all this road that's going completely unused. Waste, waste. That road could hold way more cars. Of course, we know what happens when it holds way more cars. As drivers, we don't enjoy that experience. But it's more efficient to use more of the road here, right? That really, I mean, of course it looks ridiculous on the highway, but we think it looks fine on a project plan. We think that we want to maximize the use of our time and always work on the most important thing and care about outcomes, where outcomes are a number. And that is, it kills the flow, just like on the highway. If you don't have any breathing room, you will eventually come to a stop. Your software will ossify to the point that you can't change it, that, hey, can we increase the length of this field is 2 weeks minimum, because everything is in your way, just like the cars on the highway. So that work that's not in the project plan, the little updates that we can't justify, that make our own life easier, they look like waste, but they're essential. My recommendation is that, spend 80% of your time doing stuff that you can prove is valuable, that either other people want you to do or you can explain why we need to do them. But give yourself, not a week, but, half a day, an hour here and there. If you finish your JIRA ticket at 3 o'clock, don't start another one. Please keep your work in progress lower, and instead, just do something that's going to make your life easier. I don't know, update your IDE. Convert some tests to the new framework. Do the little stuff that isn't worth the overhead of a JIRA ticket. You can't prove it's going to be worth anything, but one of those things is going to be valuable down the road. You don't know which one. So give yourself a couple hours here and there. And when you see something weird, take a look at it. Because resilience is not in the outcomes, it's in the work. It's in the day-to-day. It's in the what do we care about. Outcome-focused is necessarily narrow. Man, I don't have time to talk about, so TLDR from a post on Reddit, Southwest Airlines built really strong systems with their operational CEO and founder until he retired and finance guy takes over, and then that's why they still have software from the 1990s, because he did not invest in it. He bought a bunch of other airlines and had fun with that. Now they have a CEO who's operational, who has a computer science degree even. But that's only been for 10 months. And they started updating the systems, and they started with aircraft maintenance. Can't complain, but crew scheduling suffered. So resilience isn't really resilience unless it's sustained. You can exploit it for a while, but then it will fall. And then it will really, really hurt like it did for Southwest. Sustainable resilience cares about a healthy workplace. It cares about our relationships. It cares about customer satisfaction. It cares about profit in the long term, not this quarter, not this year. And this feels good. So I don't want to leave you with, don't be Southwest, work on resilience. No, I want to leave you with, work on resilience because the work feels good. It's good now for us individually, and it's good for everyone in the long term. I don't have time for that. So feel good about, I want to give you permission to chit-chat with each other and form those relationships. I didn't talk about cut and paste, but that's also a thing, decoupling. To poke around and see what's going on in production. Is that feature that you put in last week being used? And just make your own life easier, and don't feel bad about it. Don't block on it for a week, but do it for half a day here and there. Because as people and the software that we care for, both of these, and especially the relationship between us and the code and each other, is where we get resilience. The end. I'm Jessitron, and I'll put, eventually tomorrow, it'll be tomorrow, I'll put the references and stuff up at jessitron.com/blog, and you'll find a summary of this talk. Thank you, and I look forward to talking with you through the rest of the day.
That is excellent. So unfortunately, we don't have time for Q&A. Jessica is going to be hanging out here for a bit. If you have questions, I guess you can ask her directly too.
And I have stickers.
Sweet. So that's awesome. Thank you so much, Jessica. We loved having you, and I was beyond excited when you were available for this. So it was a great opening to this conference. Now we're going to be heading into the morning concurrent sessions. I just wanted to remind you of kind of the room location. So Ski Uma is just directly in front there, and then you have the Johnson room, which is over to my left, your right. And then we have the Heritage, which is over on this side, and the Swain, which is tucked back closer to the registration. So you have a few minutes here to grab a coffee, chill out, make a conversation, and then breakouts are going to be starting here in just a few minutes. So thank you.